Professor, I think you're muted.
Usually I forgot something, right? Now you're listening to me. Good morning, everyone.
Good morning.
Morning.
Today I'll go over section 4.9. I'll give you slowly today the idea of integrals, but not by name of integral, right? I'll call it today antiderivatives. Basically, you learn the technique of the easy technique of integration, how to integrate a function. And after test, I'll start chapter 5 with you, your last chapter. We focus a lot on last chapter because it's the main part of calculus. Excuse me, but today, only antiderivatives. I'll try to do a lot of examples for you to learn it, correct? You already received your study guide. It's in Canvas. I uploaded. Again, to do not be confused, please, Friday from 8 in our lab class, which is 8 o'clock to 9:15, I'll go over a study guide. After 9, I can start chapter 5, or I can stop at 9 and we start chapter 5 Monday, correct? It means Friday classes from 8 o'clock. Please come online at 8 if you wish to see the lecture on a study guide or working on a study guide, correct? I'll go over the study guide for you Friday, but please, even before Friday, open your study guide once. I know you already know all the problems of that. Start working on it. And if I review, it gets really easier for you, correct? Now I'm sharing the screen. If you have a question, please do not write in the chat because I cannot see it when my screen is shared, correct? Just turn on your mic and ask me. Your section 4.9, we call it antiderivatives, correct? What is antiderivative? I'll give you a formula, but before a formula, I'll explain it in an example, then a formula, then we do a lot of examples, correct? Even before starting with the formula for that, if you remember the first day of my lecture, the first day of our class, I explained there something to you. And I said, calculus has two main objectives. One of them is finding the slope or rate of change, which we call it calculus based on derivatives. And the second part of calculus, the main idea is to find areas under curves, under different shapes. It's the main idea of the calculus. Calculus has these two sections, basically. All what they created at the beginning because of these two sections. Even nowadays, we use calculus in different fields. But at the beginning, to be honest, at the beginning, they create calculus for engineers, for scientists. Most part was for engineering. That's why you see a lot of examples of physics or those kind of examples in your calculus, in pure calculus. But now we use in stats, we use in biology, we use it in chemistry. We kind of expanded, but at the beginning, the whole idea was to create calculus for engineers, because engineers are the ones that they're dealing with shapes and different kind of stuff, correct? Now, today, I'll give you an idea of antiderivatives, which you can call it integration or integrals, but not now, starting chapter 5. Look, for example, if the derivative of a function is given to me, for example, f prime of x, a function x, is x squared. The derivative is given to you. They are asking you, what is the function? Opposite way. Give you function, you can easily now, you learn all the techniques of derivatives, you can find the derivative of the function. The first, the second, the third, any derivative of the function, you can find it. Now the idea is, if I give you the derivative of a function, how to find the function based on the derivatives? Where we use usually For example, you are an engineer, correct? You know the rate, there is a water tank and this water tank has a leak. And you know the rate, by taking the derivative of the function, you can find the rate of leak, how fast you have the leak. But maybe some engineers, they want to find how much is the leak per hour, correct? In 1 hour, how much water is wasting because of leak? I want to find it as an engineer, right? This is what you learn antiderivatives. The only way is to go back like this, correct? Or an object is falling down. The rate of change, taking the derivative, it shows to find the velocity function. Now, if I give you the velocity function, you should be able to find the position function. At that point, where is my object? Correct? It's the discussion of antiderivatives. In this example, because I put really an easy function, maybe if I have enough practice, I know if I show this one by capital F, let's say, let's name this one capital F. F of x, maybe if I take the derivative of such a function, 1/3 of x cubed, it gives me x squared. It's really easy for me with a lot of practice, but for you, you need a formula. How I found this? Look, let's take the derivative of this function. F prime x equals 1/3. This exponent comes to the front times 3 and subtract 1 from exponent, 3x squared. You see 3 cancels out with 3. And you end up with f prime x equal x squared. Back to this problem, I proved it actually. It means the antiderivative of f prime x equal x squared is actually 1/3 of x cubed. Correct? Now, I'll put a definition here for you. A function let's say f, capital F. A function f is called an antiderivative of f, lowercase f, or f prime, on an interval I, f prime of x equals f of x. It's kind of confusing definition. It means, I explained in this example, if I take the derivative of that function, it should give me the given derivatives, correct? That's why they put this way the definition for you. F prime of x equal f of x. In that example, particular example, you saw that my f of x was actually 1/3 of x squared, x cubed. If I graph this function, the shape of x cubed is like this. Correct? But you see, this function is actually a family of different functions. If I change the value of, if I add a number here plus c, I can get a family of a function of cube, correct? Function of cube has a big family. That's why when you take the antiderivative of any function, you add plus c at the end. Do not forget, please, plus c. Plus c means this answer is one of the answers of the family of that function, because it can be a different function, a lot of function based on this number, correct? Then when we write this way, when we write f of x plus c, we call this antiderivative actually most general antiderivative of f. Soon after giving the formula for you, I'll explain all of them for you, correct? Now, how to do the antiderivative? Use always this formula. Basically, your f of x equals x to the power of n plus 1 over n plus 1 plus c. Using this method, you can find the antiderivative of any given derivatives or any function. I'll start now with really example, easy example. Number 1, f prime x equals x to the 5. They are asking you to find f of x. Find the antiderivative of this function. Just I'll apply my formula. Then I can say f of x equals x to the power of, how much is your n here? Your n is 5, right? Then it will be 5 plus 1 over 5 plus 1. And do not forget plus c. Simplify. F of x equals 1/6 of x to the power of 6, or x to the power of 6 over 6 plus c. This is your antiderivative. If you say no, take the derivative of this function and you will see you end up with the given problem. Easy? Let's do another example. For example, these examples that I do for you, the easy ones, they are not in your book. Which one is in the book? Later, I'll start with that one also. F prime of x equals 2x to the power of 4. They're asking you to find the most general antiderivative of this function. The most general means you should have plus c. Now, apply your formula. F of x equals, this is a constant, I'll keep my constant too, x to the power of 4 plus 1 over 4 plus 1 plus c. Then f of x equals 2 x to the power of 5 over 5 plus c, or you can write it as a 2/5 of x to the power of 5 plus c. Question, easy, difficult? You have to just remember your formula. Add 1 to the exponent, divide by the new exponent. To talk in English, right? You add 1 to your exponent and you divide your term by the new exponent and plus c. Next example. F prime x equals 3x squared minus 4 radical x. To find the antiderivatives, here first you have to change the radical to exponent notation. You can rewrite this function f prime x equals 3x squared minus 4x to the power of 1/2. Now apply your formula on the first term and apply your formula on the second term. Then you can write f of x equals 3x to the power of 2 plus 1. I shouldn't write this and immediately I should write x cubed, but these are the first examples. I'll show you the method. Over 2 plus 1 minus 4x to the power of 1/2 plus 1 over 1/2 plus 1. Then f of x equals 3x cubed to the power of 3 over 3 minus 4x to the power of, what is 1/2 plus 1? I hope your teachers in the school give you this fast technique when you add a constant. Instead of making common denominator, you can do this. This 1 times this and add here. 1 times 2 is 2, 2 plus 1 is 3. It means it gives you 3/2. This is the fastest way, right? X to the power of 3/2 over 3/2. Let's simplify. Here 3 cancels out with 3. Then f of x equals x cubed minus 4x to the power of 3/2 times 2 over 3. Agree? I simplified this fraction. Then f of x equals x cubed minus, what is 2 times 4? 8 over 3 x to the power of 3/2. Let's change it back to radical notation. F of x equals x cubed minus 8 over 3. What is x to the 3/2 in radical notation? The square root of what? X cubed. And if you simplify this, even if you want to practice f of x equals x cubed, you can keep your answer this way here, like this, or you can simplify 8 over 3 x radical x, but please do not forget c. Usually we don't write plus c plus c plus c here. We only write at the end, correct? Plus c. That will be the most general derivative of the given derivative of a function. Easy? Just one formula. X to the power of n plus 1 over n plus 1. That's your formula. That's it. Any question? Now, page 352, but I will write everything here. You have a table of some antiderivatives, but I will write here on the board. At this time, you should have a book, but if you don't have, you can make notes from here, correct? Here, I will write function. And next column is your particular antiderivative, not general. Particular antiderivative. Number 1, if I have c f of x, a constant times a derivative, the particular antiderivative will be c f of x. Remember, here I'm using lowercase instead of f prime. Here, your book is using capital F as a main function, correct? That means your left column is all prime. Your right column is the antiderivative. Number two, if you have f of x plus g of x, which I already used this technique, the particular antiderivative will be f of x plus g of x, both capital. Rule number three, the one that's the main one. If I have x to the n, the antiderivative of x to the n is your formula, n plus 1 over n plus 1. Number four. This one, please memorize. I'll give you the proof in calculus 2. The antiderivative of 1 over x. Now, let me ask you a question. What was the derivative of ln x? You use that a lot, every day. What was the derivative of ln x?
1 over x.
1 over x. Then what is the antiderivative of 1 over x? Definitely ln absolute value of x. Because it's antiderivative, right? Number 5. If you remember the derivative of these functions, you can remember easily the antiderivative. Number 5, e to the x. What will be the antiderivative of e to the x? You tell me. I'll show you the proof in calculus 2, not calculus 1. What is the antiderivative of e to the x? What was the derivative of e to the x?
E to the x.
E to the x, then the antiderivative of e to the x is also e to the x. Number 6, b to the x. The antiderivative will be b to the x over ln b. Remember? Because the derivative of b to the x ln b over ln b was b to the x. Number 7. This one everyone knows. What is the antiderivative of cosine x? Think.
Negative sine x.
The antiderivative of cosine x, negative sine x or sine x? What was the derivative of sine x?
Sine x. It's sine x.
It's
the
not
derivative of
negative.
sine x was cosine x. Then the antiderivative of cosine x is sine x. Number 8, sine x. What is the antiderivative of sine x? Negative cosine x, because the derivative of cosine x was negative sine. Number 9, secant square x. Idea. The derivative of which trigonometric function was secant square?
Tan x.
Tan x. Then the antiderivative of secant square x is tan x. Number 10. Secant x tan x.
Secant
The
x.
derivative of which function is secant x tan x?
Secant x.
Secant x. Number 11. 1 over square root of 1 minus x squared. The derivative of which function is 1 over 1 minus x squared?
Sine negative 1x. Or sine exponent negative 1x.
Inverse sine x, yes. Please read that carefully. Inverse sine x. Thank you. Yeah. You have to memorize these formulas, guys. You're in calculus soon. You need all of them here, not on a paper, right? because I'll come to your house and I'll burn all the papers. I'll check on you that you have it, you saved it here in the main server. Number 12, 1 over 1 plus x squared. Inverse tan x. There are two more in your table and your book. I didn't bring them here because I didn't teach you the hyperbolic trigonometric functions. It's way kind of above. I don't know if professors in Narco College went over the hyperbolic trigonometric functions for you in trigonometry class. That's why I avoid that part. I just these 12, correct? These are a table that at least gives you the idea of antiderivative of some functions, like 12 functions, correct? Again, please, if you remember the derivative of these, if you already memorized, the antiderivative is the same, easily you can convert, correct? But at least you have to memorize one column. Now, some examples from your book. Example number 2 of your book. Find all functions of G f or such that G prime of x equals 4 sine x plus 2x to the power of 5 minus a square root of x over x. They are asking you to find function g. Find all functions of g. It means find the most general antiderivatives of g. It means you should have in your answer plus c. To start with, I do first some algebra, even before going to g. You see here I have a fraction. I want to write it as a separate terms, correct? Then I will write g prime x equals 4 sine x plus, here, can I write as a 2x to the power of 5 over x minus x to the 1/2 over x? Or you agree with me? I separate those two terms. Let's simplify those two terms. Then g prime x equals 4 sine x plus, what's the answer for this term? 2x to the power of 5 over x. 2x to the power of 4, right? Minus, what is your answer here? X to the 1/2 over x. It means what?
Negative 1/2.
X to the negative 1/2. Because here you apply the exponent rule, right? If you have a to the m over a to the n equals a to the m minus n. Algebra, it gives you x to the power of negative 1/2. Excellent, good job. Now, let's start with antiderivative. Then g of x equals 4. What is the antiderivative of sine x? I just gave you a table. The antiderivative of sine x is negative cosine x. Plus 2, apply your formula here. Add 1 to the top. Should I write that part for you? Or you can just write x to the power of 5 over 5. Let me show at least in this example also. X to the power of 4 plus 1 over 4 plus 1 minus x to the power of negative 1/2 plus 1 over negative 1/2 plus 1. Let's simplify. Even if you wish, even you can put here also C and continue with C. As soon as you take the antiderivative, put your C before you forgot. I usually put in the answer, but you can do it from here on, correct? Then g of x equals -4 cosine x plus 2/5 x to the power of 5 minus x to the power of -1/2 plus 1 gives you what? 1/2 over 1/2 plus c. Let's simplify a little bit more. Then g of x equals -4 cosine x plus 2/5 of x to the power of 5 minus, here simplify. It means x to the power of 1/2 times 2 over 1. If I show you this step, I shouldn't do that in calculus class, but I show you how to simplify this part, right? Then g of x equals -4 cosine x plus 2/5 x to the power of 5 minus 2 radical x plus c. We are done. This is the most general antiderivative because of this C. We call it the most general antiderivatives. Please make a note. You should always write plus C. If you don't write plus C, it's wrong. You should have a constant at the end. It's because of family of those functions. I'll today upload the PowerPoint. I don't know I uploaded already or not, but there is a good graph that explains why it's a family, right? That you can see it in the graph. Can I do another example now for you? Let's do another one. Again, find f. This time not the most general. Find f prime x equals e to the x plus 20 times 1 plus x squared to the power of -1, and f of 0 equals -2. If they give you this value, f of 0, -2, it means they are asking for particular antiderivative of this function, or I can call it exact at this point. Correct? How to do that? Start with you are finding the general antiderivative. Apply your rule. But even before that, can I rewrite this function in a simple form? Look, I can write this one, f prime x equals e to the x plus 20 times 1 over 1 plus x squared. Can I do this? Or 20 over this? Now, let's start with antiderivatives. Then f of x equals, what is the antiderivative of e to the x? The table that just I give you today. The antiderivative of e to the x is e to the x.
Oh,
Plus 20. What was the antiderivative of this fraction in your table?
Tan inverse.
Tan inverse. Tan inverse x and plus what? Plus what?
-2.
Plus c. Not -2. It's not -2. Let's see how much is that. Plus c. Now look, f of 0 is -2. It means I have to plug x 0, and on the left side the value is -2. It means I can find the value of c. How much is c? What I do, I plug 0 and excess. F of 0 equals -2 means your x is 0. When x is 0, your y, which is f of x, this one is -2, right? From algebra. Then e to the 0 plus 20 tan inverse of 0 plus c equals -2. Let's solve it. What is e to the 0? How much is e to the 0?
1.
1. Plus 20 times. What is the inverse tan of 0? Which angle? 0 plus c equals -2. Or in your calculator, if you have a calculator, a scientific calculator, you have the pattern of inverse tan. Please type inverse tan 0 and you will see it gives you 0. Then 1 plus c equals -2. It means c is equal -3. Now plug in the value of c and your general antiderivative. This one was your general antiderivative, right? And you can find the particular derivative of your function. It means you can write f of x equals e to the power of x plus 20 times tan inverse of x minus 3 final answer. You see here, you don't have any more c. You are not writing again c because you found the value of c, correct? Look, this one, the first answer before finding the value of c, I call it general antiderivative or the most general antiderivative. This one, I call it particular. Antiderivative. Let's do another example. Find f double prime of x equals 12x squared plus 6x minus 4 and f of 0 equals 4 and f of 1 equals 1. Look, and this problem, immediately you cannot find f. There is another step. because f prime is not given to you. F double prime is given to you. When you go up in the stairs, right, you have to put your feet in this step, then in next step, then in next step. You cannot jump. If you jump, you will hurt yourself, right? In mathematics, don't jump, please. Go step by step. From f double prime, what is the next step to go? If you take the antiderivative of this function, it gives you what? F or f prime? Think. Think the opposite. For example, you are looking for the interval of concavity. What was the step to find the interval of concavity of a function?
Find the zeros in f double prime.
First find f prime, then find f double prime, then find the critical numbers, correct? But you have to first find f prime, and from f prime, f double prime. Now you are going opposite way. F double prime is given. The next step is to find f prime. Could I explain it well to you? How you are going? From f double prime, I cannot jump to f. First, I have to go from f double prime to f prime and from f prime to f, correct? Take the antiderivative of this function. I will not write the steps anymore. Look, I go this way. 12x to the power of 3 over 3 plus 6x squared over 2 minus 4 and what else?
Plus C.
Plus c. That's important. Let's simplify. Then f prime x equals 12 divided by 4 gives you 4x cubed. Plus 6 divided by 2 gives you 3x squared. Minus 4 plus c. Agree? Okay, now let's find f of x.
One question.
Yes.
We don't add an x to the 4, to the constant.
Not yet. No.
Oh.
Did I lost that part? Yes. Thank you. I had planned to explain it, then somehow I missed. Thank you. Thank you, Taylor. Ron. Here, he is right. The antiderivative of 4. How to find the antiderivative of 4? Actually, 4 means you have 4x to the power of what? 0, correct? If you add 1, it gives you 4x. Thank you. Plus c. Now simplify. F prime x equals 4x cubed plus 3x squared minus 4x plus c. Now let's go for f. F of x equals, again, antiderivative. 4x to the power of 4 over 4 plus 3x cubed over 3 minus 4x squared over 2 plus, what is the antiderivative of c? Cx, right? It's like 4 because it's a constant. You add x. And plus another constant. Let's name it what? For example, d. Now let's simplify. F of x equals x to the power of 4 plus x cubed minus 2x squared plus cx plus d. Now let's find the value of c and let's find the value of d because they gives us f of 0 equals 4 and f of 1 is equal what? 1. To find the f of 1, you have to use f of 0. You have to use this function. Correct? It means f of 0 equals, what was that function? 4x cubed. It means 4 0 to the power of 3 plus 3 0 square minus 4 times 0. It should gives you 4 plus c equal 4. This part becomes 0, this part becomes 0, this part becomes 0. It means c is equal what? 4. Let's plug in the value of c here. Then it gives you f of x equals x to the power of 4 plus x cubed minus 2x squared plus 4x plus d. Now let's find the value of d. It means plug in 1 in this function. Then 1 to the power of 4 plus 1 cubed minus 2 times 1 squared plus 4 times 1 plus d equals how much? 1, right? Because f of 1 is 1. Which is 1 plus 1 minus 2 plus 4 plus d equals 1. 1 plus 1, 2. 2 plus 4, 6. 6 minus 2, 4. 4 plus d equals 1. It means d equals negative 3. Plug in back this value here. Then f of x equals x to the power of 4 plus x cubed minus 2x squared plus 4x minus 3 is the particular antiderivative of that second derivative function that I gave it to you at the beginning.
I don't understand how you got c equals 4.
You are looking for the f of 0 and not even in this function, right? You are looking for the f of 0 in this function to find the value of c. You plug x0 and f of 0 as a 4 is given to you. It means on this side you have 4, right? 4 equals 4 times 0 cubed plus 3 0, and it gives you, when you solve for c, from there you can find c is equal 4, right? Plug in here. Look, it gives you 4 times 0 cubed plus 3 times 0 squared minus 4 times 0 equals plus c equals how much? 4. This part becomes 0, this part becomes 0, this part becomes 0, c equal 4. Right? And after you found that, bring it here.
So when it says f of 0 equals 4, we plug it in.
Because f of 0 is equal 4.
Oh, the f of 0 itself is equal to 4.
f of 0 is equal to 4. That's why I plug in there. Instead of f prime, I put 4 there, correct?
Okay.
Another example, they give you as a separate topic here, but it comes under antiderivatives.
Can you go back up for a bit? I didn't get to finish the
Sorry?
Can you go back up a little bit? I didn't get to finish the equation. The problem. Thank you. That's it.
Can I move it?
Yes, sorry.
Okay, look at this example. I'll show you, but I'll give you some time to find by yourself, correct? Then I'll solve it for you. If I give you, for example, a particle is moving on a straight line, correct? A particle is moving on the straight line. They give you the acceleration, the function for acceleration. It means they give you a of t. A of t equals 60 plus 4, and the initial velocity v0, v sub 0 or v of 0 equals negative 6, correct? If s of 0 is equal 9, find the position function. It means find s of t. A particle is moving on a straight line. The acceleration is given to you, the acceleration function, which is 60 plus 4. Also, the initial velocity is given to you, which is negative 6 centimeter per second. Let's put those values also, centimeter per second. And also the distance, the initial distance or the initial position is giving you at 9 centimeter. They're asking you to find the position function. Remember the example that I did for you on physics and derivatives? I told you that. What I told you? V is the first derivative of the position. Remember, I explained this way. A is the second derivative of position or the first derivative of velocity. Remember this explanation on that example? Now you are going this way. The velocity is given to you. The acceleration is given to you. You have to go from acceleration to find the velocity function, and from velocity function, you have to find the position function which they are asking you, correct? It means I have A of t equals 60 plus 4. To find V of t, I have to take the antiderivative of this function. Please go ahead, find the antiderivative of this function for me. Am I right? Is this the antiderivative, the general antiderivative of A? Agree? Did you find the same thing? 3t squared plus 4t plus c?
Yeah.
Okay. Now look, v of 0 is given to you. How much is v of 0? The initial velocity is given to you, -6. It means -6 equals 3 times 0 squared plus 4 times 0 plus c. This part becomes 0, this part becomes 0. It means c is equal -6. If you plug in the value of c in your velocity function here, then v of t equals 3t squared plus 4t minus 6. Agree? Now, let's find s of t. To find s of t, take the antiderivative of v. You see this arrow? You are going up. What is the antiderivative of this function? Do you have the same answer? Is this your antiderivative for Vt? Do I have a mistake? Yes, no? If I have, correct me, please. I'll make sure, when you're correcting me, I'll make sure to deduct your points on the test day because you're correcting a professor. The antiderivative of 3t squared, add 1 to the exponent, it gives you 3t cubed over 3, which you cancel 3 with 3, it means t cubed, plus 2t squared minus 6t plus d. Now, look, what else is given in this problem to you? The initial position, s of 0 is given to you, f of 0 is 9. It means here, 9 equals 0 cubed plus 2 times 0 squared minus 6 times 0 plus d. This part 0, this part 0, this part 0. It means your d is equal 9. Plug in back this value here, then s of t equals t cubed plus 2t squared minus 6t plus 9, the position function. It's fun, huh? When you go to physics class, they teach you this way. They give you the acceleration, they can ask you to find the velocity, they can ask you to find the position function, or opposite, using derivatives, they give you the position function, they ask you to find the velocity function, the acceleration function, opposite way. This was all about 4.9. An overview of integrals. Monday, I will start chapter 5. I will start with integrals. It means I will start with finding the area under the curve. For example, this is my curve. This is a point A. This is a point B. An interval. How much is this area? I will slowly show you Monday that this is your integral, this sign that is maybe famous for you, right? This is the sign of integral. Even in the cover of your book, you have this sign, right? We will discuss this topic hopefully Monday. Friday at 8 o'clock, let's do your study guide. Now, any question for me before I end the meeting? Okay, if you don't have question for me, I'll end the meeting now. Hopefully soon as I receive the recording, it will be available on Canvas. Just click there and you can kind of repeat this lecture. You can see it again and again and again. No question for me? Then have a great day.
Thank
And
you.
see you Monday, Friday at 8.
Thank you.
Thank you.
Pleasure.